In this tutorial, we're going to talk about Newton's laws of motion. Let's start with the first law. The first law of motion says that an object at rest or in motion will remain at rest or in motion unless acted upon by a force. Like the example we have here. In this example, there is gravity and air resistance acting on the ball. Now let's say that there is no gravity and air resistance acting on the ball won't come back to the player. This is how the ball would act in case there is no gravity and air resistance. In space, there is no air resistance and there is no gravity. So if two astronauts are throwing the ball for each other, the ball will never come to the ground. You can manipulate the vector of the ball so the astronaut can catch it. The astronauts need to throw the ball exactly towards each other so they would be able to catch it. So let's watch this video of a bead that is rolling on the floor. You will notice that the bead will stop at some point, and that is due to the gravity and air resistance. This bead will stay in place unless there is a force that acts on it. Now let's move on to Newton's second law. Newton's second law states that for a given force, acceleration will decrease as mass increases. It is expressed with the following formula: force equals mass times acceleration. We have already discussed this formula in the previous chapters. Let's take, for example, this bus and start with only one kid in the bus. You can see in the speedometer that the speed is 100. Now if we add kids in the bus and we start again, you will notice that the speed has decreased, and that is due to the mass that increased. And if we add more kids, the speed will decrease. This means that the acceleration is decreasing, and this shows the effect of mass on acceleration. So let's see these videos. We have the same ball, there is a small force acting on it, and then there is a large force acting on it. We can see that the larger the force, the speed increases and acceleration increases. The last law we're going to talk about in this tutorial is Newton's third law, and it states that when one object exerts a force on a second object, the second object exerts a force on the first equal in magnitude and opposite in direction. For every action, there is an opposite and equal reaction. So let's see this demonstration in front of us. We have a person walking. There is the push force of the person, and there is the reaction force of the surface on the person. So for every object around us, there is an action and a reaction. Let's say there is this vase that is sitting on a table. The weight is the action, and there is the reaction force or the normal force acting opposite to it. Or like here, two people sitting on a chair. The weight is the action and the reaction force is the reaction. Another example on what we mean by for every action there is an equal and opposite reaction. Let's say there are two people, X and Y, roller skating. If X pushes Y, then X will also be pushed back. So Newton's first law was things don't speed up, slow down, or change direction unless you push or pull them. Newton's second law of motion states that the bigger the force acting on an object, the faster the object will speed up. Objects with greater mass require bigger forces than those with smaller mass to make them speed up or accelerate at the same rate. And Newton's third law, that is action and reaction, It states that when you push something, it pushes back just as hard but in the opposite direction.